Hello everyone, this is Kritika and this is my demo video for my final project, which is for CSCI E63 Big Data Analytics course in Harvard Extension School. So the project name is basically TensorFlow and neural network applications in retail. As the name suggests, the technology that I have used for this project is TensorFlow, and the title of this project is or the overall idea of what we're trying to solve for this project is image classification for everyday apparels using TensorFlow, leveraging a fashion data set basically that has like apparels related data and labels. Wanted to quickly talk about the problem statement that we are trying to solve out of this project is that with respect to the online retail environment. So there has been an immense growth in the online retail area, and one of the main challenges that I have personally observed is that a lot of the search is currently limited to being textual searches. So the drawback, or I would say the challenges in that area, is that when it's a textual search, there's always a chance, or there's always a scenario where either the text keywords that you used were either too vague or they were too constrained. So when it's too vague, you end up getting a lot of results that you were not looking for, and the other time when it's too complex or too constrained, you would end up getting no results at all. And this happens even though there are applicable or the products that you're interested might still be sitting in your warehouse, but you are not able to give that out to your customer. The other challenge in the current environment or the online retail area is that there is a product that could be sitting in the warehouse that's of interest to a customer, but this product in itself is missing detailed product information with respect to the textual information that we put on a product. In this scenario, what happens is when you're trying to search things on text, you will never end up getting these products back to the consumer. And the idea that I'm getting to is that there's a lot of wealth that is there in the image itself that is not being put to use when you do a textual search. So that was the challenge or problem that we are tackling here. The solution or the idea that we are trying to implement here is to basically build and train a neural network that gets to train this network in order to learn features related to these apparels that we are looking at, and come to a stage where your network can then predict when you feed an input image outside of the training data set. The network should be able to predict and assign a label to that apparel. So basically, to give you an example, the network should be able to get an image of a bag and of a coat, for example, and the network should be able to say that this image that you provided was of a bag, and then that's the solution that we're trying to implement here. With respect to the challenges that I faced during this project, is one of my earliest ones was trying to get like a retail data set, especially image related, in a readily consumable format like the IDX one UByte format. That was pretty challenging for me until I came across the one that I'm using right now. The other one was these images that I'm working off are all 28 by 28 in dimensions, so they are pretty grainy and they lack clarity even to the human eye when I open up these images, which I will show you in the later process. They are not the program can not differentiate between different apparels with clarity because of the grain. It's pretty grainy and it's not very clear, and in this process I ended up getting a lot of false positives, where it was deducting a pullover as a shirt, so stuff like that. And the other drawback is to get, if you end up getting a much more detailed image repository, that slows down my process. I wasn't able to run that faster. So those are the two main challenges that I could think of so far. Next, I would like to quickly talk through what would I say is the stuff that I'm going to talk about is basically not covered in this scenario, in this program, in this project that I've implemented. But I want to quickly talk through how we can leverage this network in real life scenarios or use cases later. How can we use this neural network to feed different systems and actually have them be implemented for our users? So there were two scenarios that I could think of. One was like an image retrieval system for an online retailer, for example, where you once you have this network in place and you have the model up and running, you link it to your online warehouse. So basically what happens now is, instead of customers doing a textual search, the customer sends you a picture of let's say a sweater that she found and she's looking for. So the customer sends out a pic, it goes through your model, the model predicts what's the label. Basically it will say if this is a shirt or a sweater, and once the label is being given to the image that you just received, this label then can talk to your product warehouse and see how many sweaters do we have, how many shirts do we have, and give that results back to your customer. So that way you have an end-to-end solution implemented, where you're using one image as a reference and then looking for all other images that are close to that image and give it back to the customer, and that way the customer gets what they're looking for. The other place that we could use this was in a image-based search engine, where let's say, for example, the image that I'm showing up here, you put up an image of a dog and you're trying to look for other images of dogs, and instead of saying dog images, you put in an image and then it spits out different types of dog images that are there in the search engine. So this is just the idea of what are the future use cases that can be used for. Next, I would like to talk about the data set that we're using. So the data set that we're using is it's called, referred to as a fashion MNIST data set, and I got this from Kaggle. This was actually put together by Zalando, which is an European online retailer. The idea is that this data set, the aim right now that these folks have is to serve as a replacement for the original MNIST dataset that we have, which is basically those handwritten digits dataset. From what I read, it sounded like the current MNIST dataset has challenges with respect to it being too easy to depict if a ML algorithm can adapt to real life complex data scenarios. And basically it seems like any CNN or any CNN algorithm that runs through the current MNIST dataset gives you a 99.7% accuracy. So basically the aim is, in using this dataset, is it's complex. It still serves the same structure that we were using for MNIST, so there's no structural changes. It's still the same image structure and everything. It's just that the complexity of the images have changed from being digits to now being clothing and apparel. So you're basically running your algorithm through much more complex and real life scenarios. There was about like 55,000 training images that our algorithm is going to run through, and then there are going to be 10,000 test example. This is the link that I got the data from for your reference, and here. So just to quickly talk through how is the data stored. So the content is a 28 by 28 pixel images, and what we have done is basically flattened these images into a 1 cross 784 array where each cell will then depict if it's from 0 to 255, which is the pixel value. So I wanted to quickly show you the pictorial representation of how this data looks. So here you can see this is the test data set, and this column label is from runs from 0 to 9, which tells you that 0 being a t-shirt, 7 being a sneaker. So that's what this tells you, that this image that you're looking at is a t-shirt, for example. And then this column B to columns ADE, which is pixel 784, just describes one image. So this whole row is describing one image where each of them are each pixels, and the greater the number, the more it tells you that the intensity of the image is increasing in that area. So that's exactly how the data is being represented. Just to give you an idea, these are some images I pulled out from the program, which shows how a pullover looks, and it has a label of 2, a sneaker with a label of 7. Can you see? Next, I wanted to quickly talk about the architecture that we have used, or architecture that we have leveraged for our model. This is a 3-layered forward propagation model with 128 neurons in each layer. So basically each of these layers here will have 128 neurons. So there are going to be 3 layers, 2 hidden layers, and this there'll be an output layer. For each layer there will be linear functions, and then the linear functions values will be then passed to ReLU functions. And finally, when you pass it to the output layer, your output should be 0 to 9, basically 10 classes, where each class will tell you how much of the probability that the image that you just passed on is true for that label. I'll talk about that more later. The next is I wanted to talk about the forward propagation model. So this model that we are doing is a forward propagation model, and that's how it's making its prediction. So it's basically, to explain a forward propagation model, it's basically your data keeps moving forward, and as you see, there are 2 hidden layers and 1 output layer. So you send your input data through the first linear function, and after and you give in some weights and biases here, and once that data is then fed to a ReLU function. So the ReLU function is nothing but like an activation filter. It's like a 0-1 threshold. So the moment it's more than the threshold value, it lets the neuron pass the data to the next neuron. If it did not pass the threshold, it would not go through the next neuron. So that's basically how it feeds into different and finally the third the output layer would then send out this data to the softmax function, which will basically do is it will have a 0 to 9 as its output, and each of them would get a probability between 0 to 1, and depending on what's the highest probability, the label that got the highest probability kind of wins. So basically, if it says the shirt label got 60%, whereas everything else got less than that, then you're basically saying that the image that you just passed through was a shirt. So that's the basic structure. I see that I'm running out of time, so I'm going to be stopping this video, and I'll start in the next video. Thanks for listening.